Hello guys, so supposedly kani nga video is continuous unta to siya sa katong atong part 2 nga video about current resistance and voltage, but unfortunately I think na ay something wrong kay ni freeze ang akong screen that I didn't know nga ni freeze siya because I continued to record it and then dili makita ang akong gipang solve, and supposedly kaning transcript is actually akong gibutang dito, actually kani siya kaning naa sa Microsoft, so ako lang siyang ipadayon karon. So yeah, I think kay dili man siya maklaro, ay dili man siya makita dad ni freeze man ang PowerPoint, so I just have to uh, explain this again. So for your case, okay, so nag-stop ko dito is dito ko na kuan sa resistors in series. Okay, so resistors in series, this is actually the circuit reduction technique where we can uh, provide a distinction between series at saka parallel. So that is why ang circuit reduction technique is the most easiest at saka siya ang pinaka the easiest way to find the equivalent resistance or any electricity variable in our circuit. But of course, some of the complicated circuit kasi, especially for our technology today, dili lang kita always na makita nga in ani nga simple circuit. Okay, so anyway, so let's just discuss what is series at saka what is parallel. So resistors in series, so when there is a combination of two resistors in series, so the currents are actually both in that resistors. Okay, so meaning that if I have a circuit like this one and I connected both of the resistors in series, so there is a current flowing to R1 and R2, they are the same. So meaning that the current supplied by the voltage is actually equal to the current flow to R1 at saka R2. So as you can see here, the current I1 is just equal to current I2 is equal to the total current. However, so even though they have the same current, but generally yung R1 is not equal to R2, so based on the Ohm's law here, V is equal to IR, the voltage across each resistors in series are actually not the same. In fact, they are actually the sum of two, I mean, the sum of the voltages of R1 and R2 is actually equal to the voltage source. Okay, so the voltage source is, as you can see here, is the sum of the voltage of R1 plus the voltage of R2. Now using our equation here, so we know that this is the total voltage, diba, for the circuit. So using the Ohm's law, delta V is equal to I times the equivalent resistance or the total resistance. Okay, so the I here is actually the total current or the equivalent current, and the delta V1 is still given by I1 R1, and the delta V2 is actually equal to I2 R2. So we can cancel out I because they are the same in series. So we can get the equivalent resistance of two resistors in series. So we have this equation. But if you have n resistors or there are many resistors in series, so we just simply add all of them to find the equivalent resistance. So based on this equation. Okay. So next one. Okay. So because you add the total resistance, the formula for the total resistance is a sum of the individual resistors involved in the circuit. So basically, yung equivalent resistance mo is greater than any individual resistance. So meaning that if you want to attain the maximum resistance in your circuit, much better if you connect that one in a in series circuit. Okay? So again, that is series. That is a property of series resistors. Now how about if the resistors are connected in parallel? Okay, so what do you think will happen? So we have here a simple parallel circuit given by this. So here, so it's given by this one. So makita ninyo nga ang atoang current is now split because of what they called as the junction or node. So, kuan lang no, junction is actually the point where the three or more wires meet with each other. So, because of this junction, the current that's supplied by the battery is actually split. That is why the current is not anymore equal to R1 and R2 if they are in parallel. However, they are connected directly to the battery, these two resistors, so that is why their voltage are actually equal. So meaning that the voltage of this source is equal to the voltage across R1 at saka R2. However, their current lang is they are not equal, but actually it is just the sum of the I1 at saka I2. So definitely makuha ninyo nga relationship sa atong Kirchhoff's law. So if magpadayon ta sa ato ang discussion about direct current circuits. So anyway, let's just accept the fact that I is equal to I1 plus I2. So I1 is not necessarily equal to I2. Okay, because generally your R1 is not equal to R2. So to find the equivalent resistance in parallel, so we know that I is actually given by V over the total resistance or the equivalent resistance, because this I represents the total current. So iyahang current has a based on Ohm's law has kanang expression delta V over Req. Okay, the total voltage divided by the total resistance. So same also for I1, we have delta V1 over R1, then I2 is delta V2 over R2. Then since all of the voltages are equal, so we can cancel them out for both of the equations, for both sides of the equation. So what's left is actually equal to the 1 over Req is equal to 1 over R1 plus 1 over R2. Okay, so we have this one here. Now, to find the equivalent resistance gyud, we just have to take the inverse. So that is why naatay negative 1 diri. And if you have two or more resistors na naa sa ato ang circuit in parallel, so you just have to sum the inverse, and you just have to sum their the reciprocal, and then find the inverse. Okay, reciprocal nila. So yeah, I think that's the review lang sa inyong circuit reduction technique, because you already know what is the formula for the series and parallel circuit in terms of resistance, in terms of the equivalent resistance. Okay, but for series parallel combination, we still get the same formulation. Okay, it depends na lang kung kinsa ang series tsaka kinsa ang parallel. Okay, so mao ni ang pinaka dili po siya crucial, pero yeah, anyway, so let's start with our problem. So this is our problem. Our problem. Okay, anyway, so since we are talking in series circuit na equivalent resistance is greater than any of the individual resistance, kaya gi-add man nato sila tanan, gi-simply add sa imuhang equivalent resistance in parallel are kanang gikuan sila, kanang opposite. The equivalent resistance is less than any of the individual resistance in a parallel circuit. So meaning that if you want to attain a minimum resistance in your circuit, so you have to connect all of the resistors in parallel. Kaya para ma-minimize ninyo ang resistance. Okay? So let's have an example. So this is example 1. So I already so you can see ako na siyang resolve dali, diba? So actually naagi ni siya sa katong part 2 unta nga kuan, pero anyway wala dyan ako siya nakita. So I just have to repeat this one again. So here we have given a circuit. So this is not simply lang parallel at saka simple series, but they are just a combination of series and parallel circuit. So we have here yung 2 ohms mo is connected with 4 ohms, so they are basically in series. So remember lang na ang parallel, if makakita kag junction between two resistors, that's the time that you will kanang think twice nga kung parallel ba siya or series. Okay, so here there are junctions here. So this is junction. So basically this 4 ohms is in parallel with the series 2 ohms and 4 ohms, diba? Same also with 8 ohms, they are in parallel with 8 ohms. So yeah, Then we have to find the equivalent resistance using like a circuit reduction technique. So ang circuit reduction mo siya imong i-reduce, i-reduce, i-reduce. Mo siya og kanang analogo siya sa PEMDAS, di ba? So maguna ta sa parentheses, maguna ta sa kani hantod sa makaabot ta sa usa ka final answer. Mura ginana bitaw ang concept niya. So here we have to reduce our circuit para ato na lang mabilin kay ato na lang mabilin. So ato na lang mabilin is usa na lang ka resistor, okay? So first, unahon sa nato si 2 ohms and 4 ohms. So they are in series. Basically wala may junction diri nga nagkuan. So they are in series. So we can find the equivalent resistance of these two resistors in series as RA. So we have 2 ohms plus 4 ohms. That is equal to 6 ohms. And then we have to combine this RA together with the 4 ohms because 4 ohms and RA here is actually mahimo siya og parallel. So anyway, let's just move on to RB. So here RB is a parallel of 8 ohms at saka 2 8 ohms. So we just have to get the inverse. Okay, reciprocal, add the reciprocal and then inverse. Then we have 4 ohms. So the equivalent resistance of RB is 4 ohms. And then after that, you will, yeah. So after that, you will now move on to this one, to this RC. So RC is depende na mo kung asa mo mag-una ha. So this is like my ako ang solution, okay? So pwede ninyo bisag asa mo mag-una, but in any akong order sa akong solution. So for RC, so we can let the equivalent resistance of 4 ohms tsaka RA here as your RC. So we have 4 ohms at tsaka si 6 ohms here. This is 6 ohms dati. So that is why they are parallel. So we have to get the inverse. So the equivalent resistance of the two resistors in parallel is 2.4 ohms. Okay. Next one is so ako na po siyang gi-add ni 6 ohms kay because they are in series. So si RC ang kaning imuhang RA at saka si 4 ohms na ako na siyang gi-reduce into one resistor nga naay resistance nga RC equal to 2.4 ohms, di ba? So since they are in series with the 6 ohms, so you just simply add RC plus 6 ohms. So we can just say nga kanin siya is equal to RD, which is equal to 8.4 ohms. So RC is 2.4 and 6 ohms, so that is 8.4 ohms. And then for RE naman, so si RB is in series with the 4 ohms, so we just have to add again. So we have RB plus 4 ohms is equal to 8 ohms. Kasi 4 ohms man si RB, di ba? The next is the equivalent resistance na gyud. Ang total na gyud na resistance is actually in parallel. So meaning that 1 over RD plus 1 over RE, so the equivalent resistance is equal to 4.1 ohms. Okay? So anyway, they are just a kanang review lang ni sa inyo ha, di ba? So yeah, I think that's the answer. So next is we will now proceed with finding if the potential drop between point A and point B is 12 volts, find the current in each resistor. Okay, so if makuha kay individual current, so ang buhaton na pud nimo, di ba, kay na-reduce naman ang imong circuit into one resistor because that mamang yun ang buhaton ni circuit reduction technique. So the total resistance is equal to 4.1 ohms. So to find the individual current, so dapat imo na pud siyang bungkagon, okay? Bungkagon nimo back to the original nga circuit kung asa ka nagsugod, okay? So before doing that, we have to find the total current first supplied by the 12 volts. So you are given with the equivalent resistance, you are given with the voltage. So using Ohm's law, So the total current is equal to 2.93 amperes. Okay? So next is bungkago na to si 4.1 ohms. It is actually consists of RD at saka RE. Now since they are in parallel, so of course ang ilahang voltage is the same as the source na 12 volts. So meaning that the voltage of RD is 12 volts and the voltage of RE is still equal to 12 volts. And to find the current, so makuha mo ang current for this RD, which is equal to 1.43 amperes, and the current for RE is equal to 1.5 amperes. So you can just follow. Okay? So next, wala pa ta sa individual gud nga resistors. So we just have to bungkag-bungkag na pod si RD. So RD is actually composed of 6 ohms at saka RC. Diba? So they are in series, so meaning that they must have the same current. Okay? So the current of RD is equal to 1.43. Diba? So given na 1.43, so therefore the current of 6 ohms at saka RC is still equal to 1.43 amperes since they are in series. Okay? Then kung bungkago na po na to si RE, so the RE has a current of 1.5 amperes. So pag bungkag nimo ni RE, naa siya series nga 4 ohms at saka si RB. Diba? So these two resistors will now be equal to the current across 4 ohms at saka RB is actually equal to 1.5 amperes. Okay, so that is why we have here. And then next is bungkago na po na to si RC at saka RB. Because we are done with 6 ohms at saka 4 ohms, then bungkago na to si RC o si RB. Okay? So pag bungkag ni RC na atay 4 ohms, ug naputay RA dire, di ba? You can see here. Now since they are actually on the in like parallel circuit, so we have to make sure we have to get the voltage of RC first, where it came from, diba? So to find the voltage of RC, so that is equivalent to, how much is that? So the IC is 1.43 and the voltage is of RC is the resistance of RC is 2.4 ohms. So you just have to multiply this one and we have 3.43 ohms. So they are in parallel, so si 4 ohms kaya naa siya voltage nga 3.43, si RA pod kaya na voltage nga 3.43. Okay? So now proceed to current. So we have to find the current for 4 ohms kani siya. Okay? Okay, since naa natay voltage niya, na natay resistor niya, so the current is actually equal to, is the current naman to siya. Okay, nara. So the current of I 4 ohms is, we just have to divide the voltage of 4 ohms, which is equal to 3.43 divided by 4 amperes, 4 ohms. So the answer is 0.86 ampere. Okay, so muna siya ang iyahang current across 4 ohms. And then how about the current across RA? So you just have to divide again 3.43 and then 6 ohms kasi the resistance of RA is 6 ohms. So the current across RA is 0.57 amperes. Okay? So before that, before na to bungkagon si RA, ato sang tan-awon ni si kaning nasa ubos kini si duha ka 8 ohms. So what is the voltage, what is the current across 8 ohms? Okay? So remember that kani siya is coming from, asa gini siya gikan? Coming from RB, di ba? So si RB kay na ay resistance nga 4 ohms, so we have to find the voltage of RB, and we already know that the current of RB is 1.5 amperes and the resistance is 4 ohms, so we just have to multiply to find the voltage, which is equal to 6 volts. So therefore, since pagbungkag nimo sa RB is composed of two parallel 8 resistors, 8 ohm nga resistors, so they must have the same voltage as your RB. Diba? Kay same naman sila dapat o voltage. So Si 8 ohms kay naay voltage nga 6 volts, si 8 ohm po di sa ubos naay voltage nga 6 volt. So basically they have the same resistor, same resistance of same voltage, so they must have the same current which is equal to, so you can follow lang dali, which is equal to 0.75 amperes. Okay? Okay, so next. Okay, so we are done. Naapa si RA. So si RA is composed of 2 ohms and 4 ohms which is in series. Now the RA, so first we have to find muna the RA. Diba? So kung na to si RA, the RA is 6 ohms. Pero naman siya yung voltage nga 3.43. So kung na to iyahang current, which we already did na ay 0.57. So i-check lang yung calculator ha if you have one in your, in your side. So kung sakto ba ang ato ang current of A or atong mga calculations, okay? So since they are in series, so therefore they must have the same current as your RA, which is equal to 0.57 amperes. And that's it. That's the current in each resistor. So next is we have to find the we have to determine the current I through the battery. Okay, so we have this ano here naatay kanang kuandari kanang circuit given, circuit diagram. So let me check kung ako ba na siya solve here. Oh yeah, so nara siya. So ato lang pangitaon is the total current I. So the I here is actually the supplied current from the battery nga 17 volts with internal resistance nga 0.2 ohms. So naa siya internal resistance na. So di na siya ideal source. Okay, so unlike sa atong first nga circuit diagram. So I here is actually the total current. So to find the total current, we have to find first the total resistance of the circuit para makuha na tong total current. So anyway, we have to make sure nga dito ta mag-start, dito ta mag-solve og resistance, dito ta magsugod og solve og resistance sa katong wa na connection na. Okay? So you will not start here, okay, because napaman siya other connections here. Okay? And you will never start with the okay, since naman siya connection. So basically doon kayo sa last nga magsugod kasi wa naman siya connection. 'Di ba? So as you can see here, there are no junctions between 19 ohms at saka 5 ohms. So they are in series. So we just have to simply add them. So 19 plus 5 is 24 ohms. And then this will reduce to kanang usa ka resistor nga naay resistance nga 24 ohms. And these 24 ohms are actually in parallel with 8 ohms. So mo nang to find their equivalent resistance, which is RB, yung pinaka next na step. Okay, to reduce the circuit is we just have to get the inverse, which is equal to 6 ohms. And then this 6 ohms is mahimo na siyang 6 ohms di ba? Kaya na-reduce naman siya. So the 6 ohms is actually in series with the 15 ohms. So that is why makita ninyo i-add na nato siya, which is equal to 21 ohms. And after na pud ana, this one will become usa na sila, na combine naman sila na naay resistance nga 21 ohms. So they are in parallel with the 9 ohms. So we can call this one as RD. So that is why we got the inverse and then find the equivalent resistance is 6.3 ohms. And now ang pinaka-last na gid, which is we can call as the equivalent resistance kasi siya nang gid ang pinaka-last, is the 2 ohms is in series with the resistance of 6.3. So that is why gi-add na to siya. So we have 8.3 ohms. Okay, so nanatay total resistance. So we have to find the current na. Now since ang ato ang battery is na internal resistance, so we will not directly use the V is equal to IR to find the current or the total current. So we have to use our katong definition of internal resistance. So we have this expression where the VAB is the terminal voltage, the epsilon is the EMF, and we have the internal resistance katong R na gamay. And we know that this is still equivalent to I is equal to epsilon divided by R plus R, where R here is actually the equivalent resistance. The resistance of the circuit, external circuit ha. Kani kay 0.2 ohms kay internal man na siya. Kani is the external circuit kanang dako nga R, which is equal to 8.3 ohms, and the small letter r is actually equal to 0.2 ohms. So add them, so we have 8.5, and 17 divided by 8.5 is equal to 2 amperes. So therefore, ang iyang current is 2 amperes. Okay? So yeah, I think you can follow naman. So the next nga circuit is this one. We have to find the total resistance again. Okay? So find the equivalent resistance between point A and point B. So again, just like what we said, we will not move on to the connection katong naa pa siya other connection. Okay? So meaning dito mo sa pinaka last nakatong wala na connection. So like this one, pwede mo diri mag-start. Okay, wala naman siya connection diha, wala may other connection sa 2 ohms at saka ni 3 ohms pod, or pwede mo mag-start dali. Wala may connection si 5 ohms at saka ni 12 ohms. So it's up to you. You have to evaluate kung they are series ba or in parallel. So I will just start with the series one katong nasa babaw, si 3 ohms at saka si 2 ohms. So they are in series, so we just have to add them. So I can call the equivalent resistance as RA, which is equal to 5 ohms. And then this RA is in parallel with the 6 ohms. As you can see, they are separated by a junction. So sila, they are in parallel. So you can see nga nagkuha kong inverse. So we have 1 over 5 ohms plus 1 over 6 ohms raised to negative 1 is actually equal to 2.73 ohms. So meaning, na kani siyang circuit is na-reduce siya into 2.73 ohms. And then this 2.73 ohms is actually in series again with the 7 ohms. Okay, as you can see here. So that is why I add them together. So we have 2.73 plus the 7 ohms, which is equal to 9.73. Okay? So therefore, na-reduce niya siya into 1 resistor, di ba? So we have 9.73. So this is actually the reduction technique. So akong ipang-reduce na tanan. So we have here the RC, which is equal to 9.73, but RC is parallel with 12 ohms at saka 5 ohms. So you just have to get the inverse, add the reciprocal, then take the inverse, and the total resistance of these 3 parallel resistors is equal to 2.59 ohms. So that is RD. And we can now reduce our circuit into this one, where the RD is actually in series with the 9 ohms ng external sa katong circuit, na katong complicated kaysa sulod, di ba? So na-reduce na siya. So they are in series, so we can add them together kay series naman sila. So 9 ohms plus RD, which is equal to 2.59, so that is equal to 11.59 ohms. So we have to find the, we have to find the equivalent resistance. So yeah, yan ang equivalent resistance. So next is a current of 5 amperes flows into the circuit in a point A at saka point B. So basically, since the 5 amperes is the one that is flowing at point A at saka point B, so therefore siya ang total current, di ba? So meaning that we have to find the potential difference that applied A to B. So si A to B nga potential difference is actually the kung asa nag-exist ang terminal sa imong battery. Okay? So i-connect lang nato ang A ug B to a battery. So we can find the total voltage, the VT, simply multiply 5 amperes, which is the total current, times the equivalent resistance, so that is equal to 57.95 volts. So mao na iyahang voltage, okay, for this one. Okay, we have 58, so you have 57.95. The next is we have to find the current across 12 ohms. So asa man si 12 ohms? So naa siya diri. So to find the current of 12 ohms, so ato siyang bungkagon. So atong Req, bungkagon nato into smaller bits. Okay, smaller bits. Okay. So anyway, so yeah. So we have the equivalent resistance is composed of 9 ohms at saka Rd, and the 57.95 volts, kung ato siyang i-connect ni 57.95 volts, which is actually the assumption of letter C. So i-connect siya, then therefore pag connect niya is ang iyahang current across 9 ohms at saka Rd is 5 amperes because they are in series, di ba? So next, dili man na mao atong aim, so ato sang bungkagon sa Rd. So Rd is composed of Rc, R12 at saka R5, which are both in series, ay in parallel. So meaning that they have the same voltage. So to find the voltage is you simply multiply the resistor of Rd, okay, 2.59 ohms, at saka the current flowing to Rds, which is 5 amperes. So that is equal to 12.95 volts. And since they are in parallel, so the current or the voltage across 12 ohms is 12.95 volts. Diba ka, they are in parallel man. So ato mang gipangita kay current, so just simply divide the voltage and the resistance of the 12 ohms. Okay, so the current is equal to 1.07 amperes, so which is actually our answer here. Okay? So next, naapat tayo next. Okay, so naapat tayo. Next problem. So we have to find the total. Sa may gingon ninyo? Find I1, I2, and I3 and the current through 12 ohms. So we have to find I1, I2, and I3. So basically, so let's evaluate. So your source is naa siya EMF na 27 volts pero naa siya internal resistance nga 1 ohms. So ga-supply siya og current nga 1 I1, so meaning that I1 is actually the total current of the circuit. Then at junction C or at node C ni split siya to I3 at saka I2. So basically we have to find first muna the total resistance para makuha na to si I1. Okay? So to find the total resistance, you have to reduce the circuit and you have to evaluate kung kinsa si series, kinsa ang parallel, if ever naman ang imuhang combination is composed of series at saka parallel circuit. Okay, here, obviously they are composed of series at saka parallel circuit. So I just have to start with this parallel circuits. So we have 12 ohms, 6 ohms at saka 4 ohms. So they are in parallel, so simply just get the reciprocal and get the inverse. So we get 2 ohms. And then also this one, we have to reduce first this one. So they are still in parallel, so you have to get the inverse, which is equal to 4 ohms, ang ilang equivalent resistance. And then this one, this RA, nahimo naman siyang RA, di ba? Nga na ay 2 ohms nga resistance. So this is in series with 22 ohms. So simply add them. So we have 2 ohms plus 22 ohms is equal to 24 ohms. And also this one is in series with 8 ohms. So we have 8 ohms plus 4 ohms. That is 4 ohms actually. So nawala lang siya. 4 ohms na siya. So that is equal to 12 ohms. Okay, so ayaw lang mo kabalakang nga nawala siya dito. Okay, ako ang laptop ready kay okay, sorry. Okay, so now nanamantay ko niya. This is RC and this is RD. Now RC and RD is parallel with each other because they are connected by a junction. Diba? So therefore, we have to get the resistor using its reciprocal. So we can get the equivalent resistance as the 8 ohms. And then after that, we can now find I1 at saka I3. Okay, so the I1 is the equivalent resistance. So we will use this one because the voltage source as actually kanang kuan is actually ana siya internal resistance. Okay? So we have 27 volts divided by the total resistance plus the internal resistance of 1 ohms. So the current I1 is 3 ohms. Okay? So now, dili na to kailangan bungkagon na nato siya dili nga parts kay since I2 I3 raman, di ba? So si I2 ang ni flow across RC and si I3 ang ni flow across RD. So we just have to simply get the IC. So IC is actually equal to I2, that is VC divided by RC. So the RC is actually 12 ohms. So just divide them. So we have 24 volts divided by 12 ohms, which is 2 amperes. And the ID here, this actually ID, sorry, or the I3 is VD over RD. So we have 24 volts divided by 24 ohms, that is equal to 1 ampere. So by the way, the 24 volts, kay they are in parallel, so they have the same voltage, di ba? So to find the 24 volts across RC and RD, so they have not the same, they are not the same with the EMF na 27 volts kay na may internal resistance nga 1 ohm. So that is why yung paggawas lang ng terminal voltage is 24 volts. So you have to make sure to use this equation to find the terminal voltage. We have the EMF, which is equal to 27, and we have minus I1, which is the current na ni-flow sa imuhang resistance R, which is 3 amperes, and times 1, so we have 24 volts. I think that's it. That's the end of our discussion. So yeah, so to find the current through 12 ohms, so you just have to do the math as your practice. Okay, so for now, I think that's it. So the next slide will be on the other video. Okay, I think that's it. Yeah.